What's up, guys? Derek, moreplates.com. Today we're going to be talking about the genetic mutation study that was done on Flex Wheeler, and what I've come to learn is actually a number of other Mr. Olympia competitors, as well as other top IFBB pros, powerlifters, and other elite athletes. So it's a really insightful study, and I'm not sure why nobody has gone out of their way to dig this up, but it's extremely interesting. It delves into myostatin inhibition, deletion, and the double muscle phenotype that you see in cattle famously, and how this relates to humans and genetic phenoms like Flex Wheeler. So it's theorized in the bodybuilding community that the reason Flex Wheeler and other top Olympia caliber bodybuilders are able to build such incredible physiques is due to myostatin deficiency. So other popular theories circulate around that include ideas as vastly different as androgen receptor sensitivity is higher in top bodybuilders, to the complete opposite side of the spectrum where some believe that it's just training past a certain pain threshold and that's what separates champions from the rest, and genetics are just a small factor in determining bodybuilding success, and whoever worked harder than the next guy is going to, do better. And in this video, I basically delve into the gene mutations themselves, claims about top Mr. Olympia bodybuilders' DNA, and outline what kind of potential impact myostatin has shown to have in the clinical data. So in addition, I also am going to talk, the study about Flex Wheeler, obviously, and a handful of other Mr. Olympia competitors, and show what was actually revealed about their DNA, as well as how it compared to average individuals. And I found it very, very insightful. So getting into the gene itself and its role in myostatin production. So the MSTN gene is a gene that makes instructions for producing the protein myostatin. It regulates skeletal muscle growth by restraining it when necessary. In turn, it prevents the body from gaining too much muscle. So current research that surrounds myostatin is based around its treatment for musculoskeletal degenerative diseases, and coincidentally, animals that have mutations in the encoding gene MSTN show greater muscle mass strength, and in some circumstances reduced body fat as well. And examples of myostatin deficiencies are found in lab-based rodent models, as well as in the farming industry with myostatin deficient cattle. So the myostatin knockout mice are mice that lack the gene that creates myostatin and have approximately twice as much normal muscle mass as normal mice. So this is, a lab study to assess the impact it has on the development of these mice, and as you can see, blatantly has a significant impact on muscle accrual. So myostatin inhibitors have been proposed by many to be the most promising new area of science in a bodybuilding context, as well as potentially being a better alternative treatment for muscle wasting diseases. The Belgian blue double-muscled cattle is another example. So they have a myostatin gene mutation, which, consequently prevents its feedback loop of muscle growth inhibition from working correctly and interferes with fat deposition. And the ultimate eventual result is accelerated lean muscle growth. And the acceleration of muscle growth in Belgian blues is due primarily to physiological changes in the animal's muscle cells from hypertrophy to a hyperplasia mode of growth. So this growth occurs in the fetus and results in a calf being born with 2 times the number of muscle fibers as a calf without a myostatin gene mutation. So this is interesting to note because it may elucidate certain conclusions about the gene itself that may influence whether or not myostatin inhibitors are really a therapeutic treatment option to begin with, because it seems like a large portion of this growth may, at least in the Belgian blues, is mediated before birth even occurs. So in the fetus, these calves are born with twice the number of muscle fibers, and then now that they have those muscle fibers, they can induce hypertrophy in throughout their growth phase. That's the result of them getting hypermuscular, not necessarily that throughout their growth phase they had an inhibition of myostatin. So that's notable. The next thing that should be noted is myostatin elevates in response to androgen. So obviously there's very likely other counter-regulatory mechanisms in the body that inhibit excessive muscle growth, and the main factor appears to be myostatin elevation in certain data. So myostatin increases to prevent you from gaining unhealthy amounts of muscle. We already know this, and in the following study, the effects of exogenous testosterone and trenbolone on myostatin levels was evaluated, and this study showed that after 29 days of administration of either testosterone or trenbolone, myostatin levels were 197% higher in the castrated and testosterone group and 209% higher in the castrated and trenbolone group when compared to placebo. So there's obviously a mechanism in place for a reason. It's not like our bodies can just grow linearly forever. Like there's obviously some sort of mechanism in place to keep everything at homeostasis, and it's believed that myostatin is potentially the main one. So too much of anything is bad, and trying to put your body into a place that isn't healthy with insane amounts of muscle mass, obviously homeostatic mechanisms will try and regulate that. So the human body is basically just a big balancing act at the end of the day. So the theory is more androgens equals more myostatin, which equals more muscle growth inhibition. So as I previously outlined, myostatin is a growth inhibitor that elevates in the presence of androgens, and based on the current research, it appears that the higher your dose of exogenous anabolics, the greater muscle growth potential you have, and consequently the higher your myostatin will elevate in parallel, as well as other counter-regulatory mechanisms to inhibit absurd rates of muscle growth. So in a study evaluating the effects of graded doses of testosterone and what they have on myostatin levels in young and older men, myostatin levels were significantly higher on day 56 than baseline in both groups. And the myostatin hypothesis definitely isn't airtight and has some holes in the data contradicting its muscle growth inhibiting effects, like, after a certain amount of time, myostatin levels falling again, even when androgens are elevated, and a lot of things that kind of like throw the theory out for some people. But at the end of the day, the results we see in animals as well as potentially in humans is hard to ignore. And myostatin is well known to negatively regulate muscle mass in mice, cattle, dogs, and humans. Myostatin is elevated in HIV positive individuals too, which I found super interesting. So it's detectable in human skeletal muscle, and its expression is increased in the muscles of HIV infected men with muscle wasting compared to that in normal men. So does that mean that the muscle wasting that occurs with disease is caused in part by myostatin elevation? I don't know, maybe, but the relationship between the two is definitely notable at the very least, in my opinion. And as far as how much the mutation of it can actually affect bodybuilding progress, there have been some studies on certain SNPs of it to evaluate this, and one small study in particular conducted to discover if the mutations in the SNP RS1805086 have any impact on the male bodybuilding population from a muscle hypertrophy and muscle performance standpoint. The secondary aim was also to speculate if rare mutations are more prevalent in those who decide to choose a sport such as bodybuilding, as research indicates that mutations in myostatin can elicit larger muscle mass gains and a reduction in body fat. So the LISK-153 ARGR polymorphism in exon 2 RS1805086 2379 A to G replacement of the myostatin gene is a candidate to influence skeletal muscle phenotypes and is listed on SNpedia as the top risk genotype for causing myostatin related muscle hypertrophy. And in the study results, 17% of the subject groups had one mutation, the AG genotype, 83% had the common AA genotype, and 0% had two mutations, the GG. So those with the AG genotype had an average arm circumference of 46.37 centimeters compared with AA, which had an average of 42.02 centimeters. Those with the AG genotype had an average pull-up max score of 21 compared with AA with an average of 12. Those with the AG genotype had an average push-up max of 61 compared with AA with an average of 40. So the study clearly shows that those with a mutation are rare. However, the mutation does appear to give the subject a performance and size advantage over those with the common genotype. So at least based on this limited sample size. And then another study had similar findings when evaluating A55T and the same K153R polymorphism. Our results indicated that individuals with the AT plus TT genotype of the A55T polymorphism showed a significant increase in the thickness of biceps, but not quadriceps compared to carriers of AA genotype. For the K153R polymorphism, the increases in the thickness of both biceps and quadriceps were significantly higher among individuals with KR than those with KK genotypes. The results obtained therefore suggested a possible association between the two polymorphisms and the strength training induced muscle hypertrophy among men of Han Chinese ethnicity. So if you actually look at SNpedia, there's 3 SNPs definitely related to myostatin related muscle hypertrophy, at least on their site. These are the ones that have been listed. The RS1805086 SNP, RS35781413 SNP, and the RS3791782 SNP. So the RS1805086 SNP in particular is the most commonly looked at in relation to bodybuilding outcomes, and it's often referred to during discussions of the quote-unquote bodybuilder gene. The RS1805086 SNP genotype AA is seen as the commonly occurring one, with the risk alleles being the RS1805086 GG genotype. And the disease in SNpedia literally listed as a potential outcome of having this risk genotype is myostatin related muscle hypertrophy, which is, interesting. This is literally defined as a disease. If you have this mutation and you have this genotype here, the results, purportedly is having way too much muscle to the point where it's literally classified as a disease. So just having one G allele is rare to begin with, and being homozygous for it is very rare. And in my first video, I was basing my conclusion of Flex Wheeler's genetic significance solely off the extrapolation of Victor Conti's broad letter that he supposedly wrote. And I assumed that Flex probably had the rarest GG genotype for the RS1805086 SNP because it was mentioned in the Victor Conti letter that he had a rare mutation. It's not that there was a deletion or anything like that. He had a mutation that was the rarest one, and this is literally the SNP that's always referred to in the data and in the assessments of significance on myostatin mutations and whatnot in humans. So I just assumed that's what it was, but digging into the study conducted on Flex itself, we're led to a very different conclusion, and is what we're actually going to get into now after that sort of introduction to the gene and the mutation. So supposedly Flex Wheeler was a participant in a study conducted in collaboration with the Department of Human Genetics at the University of Pittsburgh involving 62 men. During this study, Flex was purportedly found to have a very rare myostatin mutation at the exon 2 position on the gene, and in theory, this supposed gene mutation prevents his body from producing normal amounts of myostatin, consequently resulting in a much larger number of muscle fibers than the average male. So, like I've talked about already, animals and humans with inhibited myostatin levels have consistently shown to have much greater levels of musculature relative to their non-inhibited counterparts, and based on this, it isn't crazy to assume that genetic freaks in bodybuilding develop their physiques as a result of a similar gene mutation. But in theory, someone with low myostatin levels could just continue to progress at rates that would be impossible for someone with normal myostatin levels, and the end result of chronically low myostatin levels could potentially be substantially greater levels of muscle gain from the exact same diet, exact same training protocol, and exact same drugs as the next guy. So talking about Victor Conti's letter about Flex Wheeler. So Victor Conti is one of the individuals associated with the myostatin mutation study conducted on Flex Wheeler and an assortment of other IFBB pro bodybuilders. 99% of those in the bodybuilding community who discuss Flex's myostatin deficiency are referencing a letter written in October 1998 by Victor Conti, and whether this letter is legitimate and unaltered is unclear, but for what it's worth, we'll just assume it's legit, as this is what has circulated around our community for years and has assumed to be true when people refer to Flex's genetic gift. So just reading it word for word, October 1st, 1998, regarding Flex Wheeler, to whom it may concern, I'm writing this letter per the request of Flex Wheeler, which is interesting. I don't know why Flex Wheeler would request this letter to be written about himself. So Victor says, I would like to first briefly provide you with some background information regarding Balco Laboratories. Balco has been working with elite Olympic and professional athletes for over 15 years. Balco has provided testing and consultation for over 250 NFL players, including the entire 1998 Super Bowl champion Denver Broncos team and the entire Miami Dolphins team. Balco works with professional athletes in many sports, including tennis, Michael Chang, Jim Courier, etc., hockey, bodybuilding, 10 of the 16 1998 Mr. Olympia contestants, track and field, soccer, and basketball, Seattle Supersonics. Balco Laboratories has been testing and monitoring Flex on a routine basis during the last year. We have performed tests including blood chemistry, complete blood count, prostate-specific antigen, anabolic hormone levels, genotyping, as well as comprehensive testing for nutritional elements. Flex's test results have been compared to 24 other professional bodybuilders, and overall he has one of the healthiest profiles. Basically, Flex is in excellent health and has demonstrated the discipline necessary to maintain a peak level of conditioning. Flex was a participant in a study we recently conducted in collaboration with the Department of Human Genetics at the University of Pittsburgh, involving 62 men who made unusually large gains in muscle mass in response to strength training. Extreme responders Flex was one of the only 9 extreme responders that had the very rare myostatin mutation. Myostatin is the gene that limits muscle growth. Specifically, Flex had the rarest form of myostatin mutation at the exon 2 position on the gene. This simply means Flex had a much larger number of muscle fibers compared to the other subjects or the normal population. We believe that these are the very first myostatin mutation findings in humans, and the results of this landmark study have already been submitted for publication. Flex was also found to have a very unusual type of the IGF-1 gene. In fact, Flex was the only participant in the study that did not have a match. All of the other extreme responders had at least 3 other subjects with a matching IGF-1 gene. Based on Flex's very unique genetic profile, we plan to expeditiously publish a scientific paper that reveals his complete genotype in specific detail. The publication of his remarkable genetic data should generate an enormous amount of media exposure. Hope this information will be helpful, and please call if I can be of assistance. Sincerely, Victor Conti, President, Bulko Laboratories, Inc. So the myostatin mutation study conducted on Flex Wheeler and the other IFBB pros is commonly referenced, but I haven't seen anyone actually dig it up and cross-reference the data in it with the statements made in Victor's letter. So everyone just assumes the statements are factual, and I was basing my first video off of that letter too. I hadn't actually seen the study myself, but I did a lot of digging and I actually found it. So the study is called Frequent Sequence Variation in the Human Myostatin GDF8 Gene as a Marker for Analysis of Muscle-Related Phenotypes. So based on what Victor stated in his letter, there were 9 extreme responders with a very rare myostatin mutation, and supposedly Flex had the rarest mutation of all at the exon 2 position on the gene, making him unique from all other individuals in the study. So the subjects that were included in this study, sequencing of selected regions of the myostatin gene and genotyping of common variants were carried out in a comparison sample of 96 randomly selected Caucasian and 96 African American subjects from the general population. An additional 72 individuals were screened for a common exon 2 variant. 153 subjects, including 127 men, 32 African American, 91 Caucasian, and 4 Asian, and 26 women, 9 African American, 16 Caucasian, and 1 Asian were categorized by the magnitude of increases in muscle mass they experienced from strength training. The subjects consisted of 18 world-class bodybuilders ranked in the top 100 worldwide. So obviously we can conclude these include top IFBB pros, 25 competitive bodybuilders not ranked in the top 100. So these could be NPC competitors, they could be amateurs in other countries, like who knows. 7 elite powerlifters, 9 university football players, 55 previously untrained subjects who had their quadricep muscle volume measured by magnetic resonance imaging before and after 9 weeks of heavy resistance strength training of the knee extensors, and 61 non-athletes who were questioned about their ability to increase their muscle mass in response to intense and prolonged strength training. So the biggest thing to note about this is that 5 of the 18 world-class bodybuilders were Mr. Olympia contenders ranked in the top 10 worldwide. So we can basically conclude that at least 5 people who were in the 98 Mr. Olympia were included in the study, one of which being Flex Wheeler. So there's 4 others from the 98 Olympia that placed in the top 10. So that is very, very important to keep in mind here. So a rating of 5 was given to those who were world-class bodybuilders and to those who increased their quadricep muscle mass by more than 400 centimeters cubed after only 9 weeks of strength training, whereas a rating of 0 was given to those who experienced noticeable increase in muscle mass after vigorous strength training for at least 6 months. 18 subjects received a rating of 5 and 13 subjects received a rating of 0. The ratings of the remaining subjects fell somewhere between these extremes. So 62 subjects who were rated as either 4 or 5 were classified as extreme responders and were compared to 48 subjects who were rated as either 0 or 1 and were classified as non-responders. Subjects were also grouped and compared by race. Information on muscle mass changes with strength training from the remaining subjects was obtained through either estimates of fat-free mass assessed by dual energy X-ray absorptiometry or hydrodensitometry, or in the case of competitive bodybuilders, powerlifters, football players, and non-athletes through questionnaire data on prior success in bodybuilding competition and or reported changes in muscle mass with strength training. So without boring you with the less relevant details in the study, the most notable part is the conclusion. The lack of a significant relationship between myostatin genotypes and overall muscle mass response to strength training suggests that response is not significantly influenced by variation at the myostatin locus. However, it is interesting to note that 3 of the African American non-responders were homozygous for the less common ARG allele at the exon 2 K153R site, while none of the responders were homozygous for this allele. 3 of the 5 mutations causing the double muscle phenotype in cattle occur in exon 2 and are recessive, but 2 are chain termination mutations, and 1 is a deletion, expected to produce a non-functional myostatin protein. Whether variation in the myostatin gene influences muscle phenotypes other than the muscle mass increase in response to strength training requires further exploration. The less common ARG allele that is being referred to in the study conclusion is the mutation that you would expect Flex Wheeler to have, but it doesn't appear he has it. Sandwiched in the middle of the study, though, is a mention of what may be highlighting the true root of Flex's genetic superiority, and it's something I almost skimmed over. So among the 6 nucleotide changes, 2 P198A and the intron 2 AG were observed in a single individual, and 2 I225T and E164K were observed in 2 individuals, always heterozygous with the wild type allele. The remaining 2 were present in the general population as common polymorphisms. The A55T and K153R variants are common in both ethnic groups, with the less frequent allele having a 3 to 4 times higher frequency in African Americans. These variable sites have the potential to alter the function of the myostatin gene product and could alter nutrient partitioning in individuals heterozygous or homozygous for the variant allele. What we can presume to be the nucleotide changes that Flex Wheeler has aren't even mentioned on SNPD's list of related risk genotypes. The only vague reference we have to it is in a study that examined the association between the myostatin exonic variants and explosive leg power in 214 male university students, and in that study, the only thing mentioned is that no subjects in the study had the myostatin exonic variant P198A. So it appears that despite the uncommon ARG allele at the exon 2 K153R site being the main focus of most myostatin papers and being owned in on as the root of the quote-unquote bodybuilder gene, it does not seem to have as significant of an impact on muscle growth response to training as many thought at the end of the day, which is, contradictory to my first video I did, which I assumed he had this, the GG genotype for this SNP in particular, but it doesn't appear so. The lack of a significant relationship between myostatin genotypes and overall muscle mass is very notable, as this study included 5 Mr. Olympia caliber bodybuilders and several other top tier IFBB pros. And the most interesting thing to note is that 3 of the African American non-responders were homozygous for the less common ARG allele at the exon 2 K153R site, while none of the responders were homozygous for this allele. So of the identified GDF8 variations in humans, the K153R polymorphism in exon 2, RS18050862379 A to G replacement of the myostatin gene is a candidate to influence skeletal muscle phenotypes in the clinical data in a lot of studies that have been done to date. None of the extreme responder bodybuilders were homozygous for this allele though, and I had mentioned in the first video that having the AG genotype in general is rare, and it was found to have a fairly significant impact on muscle size and muscle strength in the study I outlined earlier in this video and in the first video. And logically you would assume that the GG genotype, which is even more uncommon, would result in a lack of myostatin and some insane level of muscle growth, but that just doesn't seem to be the case based on this study. 3 of the subjects who had a poor response to training and subpar muscle growth, non-responders, were the ones who had this rare genotype. Only 3 individuals had extremely rare nucleotide changes, and the individuals who I assume to be Flex, who has the 2 nucleotide changes, P198A and the intron 2 AG, and 2 other individuals having I225T and E164K nucleotide changes, all of which were heterozygous for the wild type allele. That leaves 2 top tier Mr. Olympia caliber bodybuilders and several other world-class IFBB pro bodybuilders, and a lot of other elite athletes with myostatin genotypes that have shown to have a minimal impact on muscle growth response to training in this study. The 2 other nucleotide changes causing the double muscle phenotype in cattle are the A55T and K153R variants and are present in the general population as common polymorphisms. These variable sites have shown potential to alter the function of the myostatin gene product and could alter nutrient partitioning in individuals heterozygous or homozygous for the variant allele. However, the data in the study shows that there is not a significant relationship between myostatin genotypes and overall muscle mass response to strength training. So I don't know where the statements in the letter Victor wrote are coming from. He claims that Flex Wheeler had the rarest form of myostatin mutation at the exon 2 position of the gene. So when we look at the study though, it says 3 of the non-responders were homozygous. None of the responders were homozygous. Flex Wheeler would have undoubtedly been categorized as an extreme responder, and yet he was not one of the individuals with the GDF8 variation in humans we would expect to see in a myostatin deficient individual. So based on this, we can presume he is the individual mentioned in the study with 2 nucleotide changes, like I mentioned, P198A and the intron 2AG. Victor also mentioned how 9 extreme responders had the very rare myostatin mutation, and we can see in the data that only 3 individuals had uncommon nucleotide changes, not 9, and the rest of the subjects had common polymorphisms present in the general population. And in addition to that, of the mutations mentioned, even if more of the top caliber bodybuilders had notable mutations, the study conclusion still states that there is not a significant relationship between myostatin genotypes and overall muscle mass response to strength training. Victor also stated in his letter that Flex is one of the healthiest of his professional bodybuilders he's been monitoring, and that Flex is in excellent health. And he's quoted, "We have performed tests including blood chemistry, complete blood count, prostate-specific antigen, anabolic hormone levels, genotyping, as well as comprehensive testing for nutritional elements. Flex's test results have been compared to 24 other professional bodybuilders, and overall he has one of the healthiest profiles. Basically, Flex is in excellent health and has demonstrated the discipline necessary to maintain a peak level of conditioning." So this was written on October 1st, 1998. And if you know the history of Flex Wheeler, you'll know that he ended up having to stop competing after discovering in 1999 that he had a form of kidney disease, and then retired shortly thereafter, a few years later. And I don't know how something that massive could be overlooked to that extent, and it makes me question the legitimacy of this letter in the first place. I don't know if Victor actually wrote this, if it was just something, conjured up on forums to, stir controversy or what, but if Flex was truly on the brink of kidney failure, I don't see how it was determined that he was one of the healthiest bodybuilders being supervised by Victor, and how this extensive testing didn't pick this up. If this letter is legit to begin with, the first thing that comes to my mind is curiosity around whether or not there was some sort of money-making endeavor associated with all of this. Like the supplement industry, I'm sure was crazy in the 90s. You could sell steroids over the counter legally, you could make ridiculous false statements about pretty much anything you wanted, and no one would be the wiser, because it's not like you could cross-reference it very easily with data on, clinical studies and stuff. Back then, it was the conception of the internet. You couldn't just go on a forum and figure out if something was fake or not. You had to just, literally use your best judgment when it came to supplements and word of mouth and stuff like that. And the false claims are still around today in the supplement industry, obviously, but now we have the resources at our fingertips to actually see through garbage being marketed to us, whereas in the 90s, nobody knew better, and a myostatin inhibiting supplement that can make you as jacked as Flex Wheeler likely would have sold like crazy. And maybe this is way off of what the real intention was, but I don't see what could have been the motivation behind this letter or what it was seeking to accomplish. It's entirely possible that they were thinking of teaming up to create some sort of myostatin inhibitor supplement that would be based on Flex's unique genotype, and I'm sure that would have sold like crazy. And I don't know if the letter itself was addressed to somebody per the request of Flex Wheeler. I don't understand what the goal of the letter was. There's several inconsistencies between it and the actual study that would need further clarification to make any conclusive statements on this myostatin mutation. But who was the letter addressed to? Why was Flex Wheeler requesting this letter to be written in the first place? Honestly, that's one of the things that I'm most curious about. And I don't know if the further publication that Victor mentioned in the letter ever came to surface, where he said, based on Flex's very unique genetic profile, we plan to expeditiously publish a scientific paper that reveals his complete genotype in specific detail. The publication of his remarkable genetic data should generate an enormous amount of media exposure. So I'm assuming this was probably put on the back burner after Flex had his health issues in 1999, but I don't really know what to make of that letter, to be honest, aside from the mystery of it, and, greatly piques my curiosity. It seems like we can at least conclude based on the study findings that most myostatin gene mutations do not appear to be the differentiating factor between top Mr. Olympia caliber extreme responders and the average Joe. So take from that what you will. Let me know what you guys think in the comments down below. Drop a like, please subscribe, hit the notification bell if you want to get notified every time I post. Also, follow me on Instagram at moreplates_more_dates, Facebook, Snapchat, Twitter, TikTok, BitChute, any other platforms I'm on. Podcast link in the video description below as well. Really appreciate when you guys post ratings, 5-star ratings there. Helps the algorithm there as well. And obviously the comments here are very welcomed as they help the algorithm here and helps push my content to a new audience that may have otherwise not seen it. So thank you guys again for doing that. Thank you guys for watching. Talk to you soon.